Okay. So is my screen visible? Okay then. Okay, let's start. So in the last class, we discussed about the data types, then the control flow statements and the operators also. And today we are going to continue our discussion. So the first thing we are going to discuss is the functions, the use of functions in Python, right? So what is a function? A function is a named section of a program that performs a specific task, and functions can take inputs, process them and return an output. They take some inputs and they give you some outputs, exactly like the mathematical functions you use in mathematics, right? So they help break down complex tasks into smaller and manageable pieces, right? So exactly like mathematical functions, you have functions in Python. So defining a function, in Python we define a function using the def keyword. So the keyword is def, def. Using the def keyword, you define a function followed by the function name. You give the function a name. Like in mathematics, you usually write f of x or g of x, right? Then the parenthesis, and inside those parentheses, you usually give the inputs, right? Like in the f of x, you give the input as x, the variable x as the input, and a colon. And the function also the function's code is code block is indented. So this is how you can write a function, and here is the syntax, right? The first you start with def, def, then the name of the function, and then inside the parenthesis there are the parameters, right? And there is this colon, and below it you write all your code, and there is also a 4-space indentation, right? So here this 4-space indentation, 1 2 3 4, this 4-space indentation defines that all these things here, all these things below this line are inside this function, right? So here is an example. In this example, you see we are defining a very simple function, that def greet. So first you write def, you are defining a function, and then the name of the function. The name of this function is greet. This is a simple function that prints a greeting, and you see there is this parenthesis, and inside these parentheses there is no input. There are no parameters given. This function has no input, and then the colon. Here is the colon, and below it you write all your program, and here it is printing just hello there, right? Now if you run this function greet like this, to run this function just write its name and give the inputs if any there, then greet with parenthesis, it will print hello there. Or if you change it now, suppose hello there to hello Tushar, then it will print hello Tushar, right? So this is how the functions work. Then let's talk about the parameters and the arguments, right? What is a parameter and what is an argument? So here you see this is a parameter. Anything you given as input, so that is called as the parameter while defining the function. So parameters are the placeholders listed in the function definition. When you are defining the function, you write something here to take as input, right? So these are just placeholders that are listed when you are defining the function. They represent the data that the function will accept when it is called, right? They represent the data the function will accept when it is called, and arguments are the actual values passed to the name when calling it. right? So here you in this example you see that this is another function, the usual greet function, and there is this parameter here. Now in the first case there is no parameter given, but here there is a parameter name, right? And here I am printing that hello name. So whatever name you give here while calling this function, it will print that, right? So when I print greet Sagar, it will print hello Sagar, and if I print greet Luke, it will print hello Luke. Or if I print here uh, hello Sir again, and it will print hello Tushar, right? So here this name is the parameter, and this Sagar and Tushar, all these things are the arguments, right? So these the arguments are the actual values passed when the function is called, and this name is the parameter. These are just placeholders for the arguments, right? Is it okay, or is there any doubt? Oh, okay. So yeah. So I have never used C. So do you know C? Yeah. Okay. So I actually never used C. So this is the only programming I know. In the BSc time I tried to learn C, but that was a bit difficult, and I also forgot everything about C. So yeah. So maybe uh, in C also the syntax is same. Yeah, it's okay. And in C or C++, the syntax are mainly same. Okay, so that is how you give parameters and the arguments to the function. Then the default parameters, right? So Python allows you to define a default parameter value, which are used if no argument is provided. Suppose there is no argument to the function when you are calling it. So there may be a default parameter, and that can be your argument, like this here. And you are defining this greet function, and here when you are defining it, you are giving an argument to this name function. So originally when you define the parameter there is no argument, but in the definition of the function itself there is a argument to the parameter. To the parameter name there is an argument in the definition of the function itself, right? So here if you print hello name, and now if you call this function using a name or using an argument, a different argument, hello greet Anakin, it will print hello Anakin. But if there is no argument given to the function while calling it, right, so it will just print the default argument Skywalker, right? So if there is no argument given to the function, it will print your default argument while defining the function. So that is how you give default arguments to the function. Okay, so that is how you define the functions. So this is all about functions. So also you may write some other functions also. Here if I define a function sum is, it takes two inputs or two numbers x and y, and it will return, not using print, it will return x plus y, right? This is a very simple function, the sum function. It will take two inputs and it will return their sum. So here if I call it sum 3, 4, right? So what will it print? It will print 7, right? So here if I print the arguments are 4 comma 4, then it will print 4 plus 4 is 8. So that is how you can use return also inside the function instead of print. To get any numerical value, you may use the return thing here, return inside a function. Okay, so that is all about function we need. Then let's talk about inputs. You now know how to get outputs. To get outputs, you just use the print function, right? Print and write inside the parenthesis, and it will print it. Then how to take inputs? You know how to get outputs, but how to take inputs in Python? To get the inputs, we use this input function, right? So here there is a variable name, and suppose you need the name of the user. How to get it? Write name equals to input, and here inside the parenthesis write a string, and inside this string you enter your name. Now if I run it, see what happens. If I run it, you see there is something called as enter your name, and inside this box you have to enter your name. Suppose I give input Sagar. See, it will print hello Sagar. So because I am printing hello name, and what is this name? I am giving this name a input of Sagar, right? So here you get the print as hello Sagar. Now suppose you want the user's age as input. So again, input, enter your age like this, and convert this input to a integer type data. So usually when you give an input, it becomes a string. It becomes a string. So you have to convert that string type data to integer type int. Then it will give you an integer of 24. Suppose here I run it, and suppose my age is 23. Then you are 23 years old. Print you are, and then age years old. So it will print you are 23 years old, right? So that is how we take any number as input. So here is another example. Suppose you want to get several inputs at once. You want more than one input at once. So how to get it? So here you are defining two variables, number 1 and number 2, and input enter two numbers separated by a space, and here to get two inputs you use, or several inputs you use the dot split, right? So here you have to enter two numbers separated by a space. So here if I run this program, you see, so the output is enter two numbers separated by a space. So here I give two numbers, suppose 10 space then 20, and run it. It will give you sum as 30, because here first it is converting this number 1 to integer type and the number 2 to integer type, and printing its sum, and sum is number 1 plus number 2. Suppose you want to enter the numbers without a space but with a comma. So inside this split you give a comma. That is the syntax, right? Yes. So here if I write 10 comma 20, right? So here you don't want the space. Instead you want to enter the numbers separated by a comma. So enter two numbers separated by a comma, right? So suppose you want to enter the number separated by a comma, then inside this split function you give this comma as the parameter. So here if I run it again, enter two numbers separated by a comma. So here suppose 20 comma 40, it will give you the sum, right? So this is how you take inputs. Is it okay? Okay then. So now let's use all of our knowledge we have gained so far to describe an example or see an example. The task is to check a number if it is prime or not, if it is a prime number or not, prime number or composite number. You give any number as the input, you ask the user to input a number, and your code will check if it is a prime number or not. So can you think of an algorithm how to check if a number is prime or not? Suppose you have a number 7. So when it will be prime? Do you know? Yes, it is not divisible by. Yes, so it should be divisible by only the 1 or 7, right? Yeah. So here is an algorithm. Here is the algorithm. So here the algorithm is bit different. So in Python, in this language of computer, how to check if a number is prime or not. Suppose the user give an input, suppose 16. The user give an input a number of 16. So you have to check if 16 is prime or not. So how to do it? You can run the program to divide 16 by all the numbers less than 16, right? You write the program or use a for loop or anything like that. Using the for loop, you can divide the 16 all the numbers less than 16. So from 1 to 15, you run the program and divide 16 by the numbers 1 to 15. Right? If there is a number that can divide 16, then it will be composite number, and that will be not a prime number. But that algorithm is not very efficient, right? You have to suppose there is a large number given to you, suppose 1000 or anything like that. So the program will take a much longer time to divide 1000 from the numbers 1 to, right, 9, so 999, 999, right, 999. It will divide the number 1000 from 1 to 999. So that will take much time. So here there is another way to do it. Mathematically, you can think that a number will be a prime number if it is divided by 1 to square root of the number. It is divided by any number between 1 to the square root of that number. So if you want to check that 16 is a prime or not, you can run the program to check if there is any number that can divide 16 between 1 to 4. And what is 4? 4 is the square root of the 16, right? So that is also a way. That is also a mathematical argument that if there is a number, then it is a composite number if there is a number which can divide it between 1 to the square root of that number. Are you getting my point, what I am saying? Uh-huh. Yes, yes, yes. Yes, you can check it. So you see this. The square root will be. Yeah, the square root will be also large, but it is more efficient than dividing all the numbers less than that number, right? It is bit more efficient, right? Right. So it is bit more efficient than the previous method. You can do it. You can do it using your fast method, but this method is bit more efficient. So you have to run through the program using a smaller set of numbers, right? So that algorithm is used here. So here you see that when I am defining this function is prime. The name of the function is prime, and here the number is the parameter, right? So here see that, check the number if it is prime or composite. If I in range 2 to integer of number square root, this double star 0.5, that means number to the power half. So you are taking the square root of the number and adding plus 1. Why adding plus 1? Because range goes from the initial number to the last number minus 1, right? So if you write I in the range 5, it will go from 0 to 4. It will not grow from 0 to 5, but we want the range should go from 0 to 5, not 0 to 4, right? So that is why there is additional 1 here, plus 1 here. So this range must run from 2 to the square root of the number itself. Suppose the number is 16, the range must be between 2 to 4, right? So that is why we are adding this 1 here. If you don't add this 1 here, it will run from 2 to 3. It will not go from 2 to 4, right? So that is why you are adding this 1 here. Now see that for I in range, these numbers, if number percentage I equals to 0, and this is equality, not equals to, so it checks if this number divided by the numbers in this range, if it is equals to 0, or what is this percentage sign? This percentage signs give you the remainder of the division. If the number divided by that I value, if the remainder is 0, then it will return false. That means the number is a composite number, and if it is not 0, then it will return true. So it is not divisible by any number inside this range. So the function, the number will be prime number, and it will return true. And how to take inputs? To take inputs, use this try thing, try and accept thing. I have already mentioned. Here you need to take an input from the user. So here try to take an input, and your input is stored in this variable norm. So here is the input. Enter a positive integer and convert that input to an integer. Check if the number is a prime or composite number, right? If the number is equals to 0 or number equals to 1, then print that number is not prime or composite number, because you know that 0 or 1 is 0 and 1 are not prime or composite. If the function f number is a prime number, and else if it is true, it will give you the if the value of the function is true, then it will return that the function is a prime number, and if it is not true, all of these are not true, then else it will return the function is the number is a composite number. And if you enter anything than a number, it will raise a value error and it will print a valid integer. So using that try and except block, you get an input. Okay, is it okay? Okay then. So let's run the program. Suppose I enter some number like 99, suppose. What will happen? Yeah, 99 is a composite number because it is divisible by 11. Then suppose a number like 79, suppose. Yeah, 79 is a prime number, obviously. Now if I enter 0 or 1, suppose 1 is neither prime nor composite, right? It is working perfectly. Then suppose I enter anything than a valid number, suppose some gibberish. If you enter it, so it will say that please enter a valid integer, right? So this function, this program of our is working perfectly. It will take a number from the user and it will check if it is prime or not. Similarly, can you think of a program that can verify the function, the number is even or odd? Yes, so you have to check here. You can modify it. If the function %2 it is equals to 0, that means it is divisible by 2, then it will be even number, and if it is not divisible by 2, then it will be a odd number. So very easy. So try to write as many as program you want, and so there are these programs you may try to solve. So print every power of 2 less than 10,000. Write a function that takes two inputs A and B and returns the value A plus 2B. This is the easy one. So here the third program is write a function that takes n as the input and prints all Fibonacci numbers less than n. Do you know what are the Fibonacci numbers? So how to get it? Do you know how to get them? Yes, correct. So you have to take n as an input from the user, take a number as the input and print all the Fibonacci numbers less than n. So think of an algorithm and try to solve them. Okay. So that is all about functions and inputs. So let's move ahead. The next thing, the only thing remaining to study are the arrays, and the arrays are objects inside the NumPy module. So there are several modules in Python. So what is a module? So do you know the modules in C? Is there any module in C? Oh, okay then. Oh, achha. Okay. So there are modules in Python also. And what is a module? The module is just a Python file, just some name .py file. You can create a module also and use it. And first you have to import that module to your code, and then you use the defined functions inside that module. So similarly, there are default modules in in Python or official modules. So here this math module is there. So to use any mathematical function, you have to import the math module. So here you write import math. In Python, everything is very easy. The syntax is very easy than C and C++, right? So just import math, and here using that math module, I am writing this function math.sin math.pi by 2. So math.pi means just the pi value. So sine of pi by 2 is what? 1, right? So here is the sine function, and sine of pi by 2 you are getting 1, right? So this is the math module, and also there are several things in the math module, several functions in the math module available. You can search about them. So math.square root sqrt 25. So if you write this way, this will give you the square root of the number. So the square root of the 25 is obviously 5. You can import the modules as a separate name also. So here I am importing the module math as m. So I don't have to write math every time while calling a function from the module. So here I am writing import math as m. So m.sin, not math.sin. You don't need to write math again. So here I am importing the function of the module math as m. So here instead of math.sin, you may write m.sin, and m.sin 0, the sign of 0 is obviously 0. So that is how you import the modules. Now let's talk about NumPy. The only module we are going to use while dealing with this course. So the NumPy module. So this NumPy or numerical Python module is the most common package for scientific computing in Python, and its fundamental object is the array. So the main thing we use from the NumPy is array. This arrays we use these arrays to get matrices, right? The matrices are the matrices we use in mathematics are the 2D arrays. Then there are 3D arrays for several purposes, and higher dimensional arrays are also there. So they provide this NumPy library. They provides linear algebra, Fourier transform, random number capabilities. There are many things you can do using the NumPy library, like the Fourier transform. You can input take input as a function, and you can get its Fourier transform. And they are also building block of other packages like SciPy. So this is open source and huge developer community. Okay, so now let's talk about NumPy. So first you have to import that NumPy module. So import NumPy as np. I am importing the NumPy as np. You can take any other name or n. So I am here taking import the NumPy as np. So the main object of the NumPy is an array, right? So the main object type is np.array, and many ways to create an array. So let's talk about them. The one way to convert a Python list. So you can convert a list to an array. This is a one-dimensional array. Suppose here this is the Python list defined inside the square brackets, and if you print this Python list, it will give you like this. The result will be like this. Now you can convert that Python list to an array. To convert it to an array, you write np.array, and inside the parenthesis give the list as the input. So Python list inside the parenthesis. Now it will convert this list to an array, right? Here is the input. Now if I give another number 4 and convert it, it will give you the array 1, 2, 3, 4. So this is a one-dimensional array. And you can also define arrays like this also without converting any list. Directly define, you can directly define an array. This arr variable holds an array np.array. Inside the parenthesis, you have to write inside the square bracket. So first there will be a parenthesis and then square bracket and then the values inside the array. So it will generate this ARR, print an array of numbers 1, 2, 3, 5 and 6. So this is another way to create an array. So there is also a random function. So using that np.random 15, you can generate 15 random numbers in the array. So this is the random function, and using that random function you can generate a 15 random or any number of random numbers inside an array. Suppose 20, then it will give you 20 random numbers inside the array. Here you notice that all these numbers are less than 1, right? So the thing is that this random function in Python always gives numbers less than 1, between 0 to 1. So it will generate numbers between 0 to 1 only. You may give any number of input, suppose 100. It will give you 100 numbers between 0 to 1. It will never exceed 1, right? Here as you can see. Right, so this is the random module, and so this like NumPy, there is a random module also. So we are not going to discuss about them in here. So where this random module is used? This random module is used mainly while dealing with statistical mechanics problems, or the what is that called, the Monte Carlo simulations. So where you need there is a need of random numbers, right? In statistical mechanics, if you learn these things more in detail, in there is a subject known as the computational physics. You may know, in computational physics, when you study statistical mechanics or the Monte Carlo simulations, there is a need of random numbers to generate some data, right? So there this random module is used. But here we are not talking about the random module, but here just from the NumPy module we are borrowing this random function, and using that random function we can generate random numbers inside an array. So here is another example, and here you see that inside this array you are giving the numbers as input, but here you are writing with comma string str. So here instead of numbers, it will convert these numbers to a string type data, right? Here if I just remove it, see, remove it and print, it will give you numbers 1, 2, 3, 4 and 5. Now if I write comma str, that will give you strings, right? See, here this 1, 2, 3, 5, 4 and 5 are now inside the single quotes, right? So they are now converted to string type data. So inside the array they are strings now. Now if there is one string with all the numbers, that will also convert all your numbers to a string type. That is also a possibility. If there is one string inside all your numbers inside the array, it will convert them to strings. Then there is np.linspace and logspace functions. Linspace will generate. So here this is the syntax. It starts from a value, and this is start, and this is the end value, and there are how many numbers you want, right? So here that means from 0 to 1 you need 4 numbers. So what will linspace will give you? Linspace will give you or linspace is a function that returns evenly spaced numbers based on given interval. So you see that all these four numbers have the same difference, right? They are evenly spaced numbers. So this linspace will give you four numbers inside this 0 to 1 value, and they will be evenly spaced. Similarly, there is log space that generates a sequence of evenly spaced numbers in the logarithmic or exponential scale. That is something different. So it will generate the logarithmic values, or they are evenly spaced in the logarithmic scale, not in the linear scale. They are in this linspace. The numbers are spaced evenly in the linear scale, but in this log space the numbers will be evenly spaced in the logarithmic scale. And this is not very useful for our purpose. We are going to use mainly the linspace. Then there is np.range. So what is np.range? It is similar to the range function we have used beforely. Then here this np.range, it will give you the numbers from 1 to 100 like this, but it will not go from 1 to 100 itself. It will go from 1 to 99. It will leave the last number. And similarly, there is this start value, stop value 100, and there is also step value. If you want to skip a number, then you can give a step value, and here you see that it is printing all the numbers up to 99 and skipping the numbers inside them. So here this 2 is absent, then 4 is absent, then 6 is absent, right? So that is how you use the arrange function also. And here you see that for this example, it is starting from 100 and it ends at 1, and the step value is -1. So it goes in the reverse order. So from 100, then 99, then 98 up to 2, because it will skip the last value. It will go from 100 to 2 only. It will not go from 100 to 1, right? So that is how the arrange function works. Is it okay, or is there a doubt? Okay, then there are, so let's define the 2D array and 3D array. So these 2D arrays are actually used to define the matrices. So here you can see that using this 2D array, I am defining a matrix like this, and this is a 2 cross 3 matrix. There are 2 rows and 3 columns, right? So how to define a 2D array? There is usually the parenthesis is here, and then there is one square bracket, a set of square brackets. Then inside this square bracket you write like this 1 2 3 and comma, give a comma, then again the square brackets and 4 5 6. Suppose I want to create a 3 cross 3 matrix, then I write like this, again square bracket. Suppose the numbers are 4 7 and 9. Now if I run it, see, so this is a 3 cross 3 matrix, right? So the dimension is obviously 2. This is a 2D array, and the shape is 3 cross 3. M dot shape, it is a 3 cross 3 matrix or 3 cross 3 array, right? So this is a 2D array. And similarly, you can also define a 3D array, and 3D arrays are collection of 2D arrays, right? So this is this thing here inside. This is the first square bracket, and inside the first square bracket you see this is one 2D array, then comma, then there is another 2D array here. From this to this there is another 2D array, and here are the two 2D arrays. This is a 2 cross 2 matrix and another 2 cross 2 matrix. So 3D arrays are actually collection of 2D arrays. Similarly, 4D arrays will be collection of 3D arrays. and they are not very useful. So we usually use up to 3D arrays, right? So you see the dimension of this array d dot n dimensional. To get the dimension of the array, you use this method, and this will give you the dimension as 3. These are the 2D arrays, and these 2D arrays are actually useful for us because this is going to help us to define a matrix that we use in mathematics. Then there are some array operations. What operations you can perform using arrays? To perform an operation using arrays, they must have same length. That means that they must have the same number of elements with them. So here the number of elements are 4 for this array, and here also the number of elements are 4. So the length of the array is 4, and the sum of all the numbers inside this array is 25. The sum of A1, you can get all the numbers, the sum of all the numbers in the array, and it will be 25. And also you can add the arrays element wise. So A1 plus A2, it will give you the element wise addition of the numbers, 7 plus 3, 8 plus 2, like this. So it will add the numbers, then subtract the numbers inside the array, or multiply them, divide them, take the modulus value, then float division, multiply them with a number, or divide them. You can all take the inverse of all the numbers 1 by A2. So you can do all these operations using the arrays. And another important thing about arrays, that why they are very useful. They can be used to vectorize a function. You know, this is a function e to the power minus x square. E to the power minus x square, you know, this is a Gaussian function. So usually the functions like this, they take a single value as input, but you can give, using NumPy, you can give an entire range of numbers as an input to these functions. So if you write this np.exp, this is the exponential function, and it is minus x1 square. So this is known as the vectorization of the function. So you are giving a vector, right? A vector or a range of numbers as the input. So what is this linspace? This linspace will give you 100 numbers between minus 5 to 5, right? So all these numbers from minus 5 to 5, these 100 numbers are given as the input to the function e to the power minus x1 square. This is a Gaussian function. And now if I plot it, right, here I am plotting this function. The x1 is in the x1, this x1 is in the x value, and this y1 is the y value, or the value of the function. And if I plot it using the matplotlib, you will see this will generate a graph like this, and this is the Gaussian function, right? Similarly, I can write the sine function also. This is the sine function. Then like the list, there is the indexing of arrays also. The indexing is similar to the list. This has the index of 0 for this array. This has the index, this 2 has the index of 0, then 5 is 1, 8 is 2, 3, 4, 5, 6, like that. And also from the reverse order, this 0 has the index of minus 1, 67 has the index of minus 2, 32 will have an index of minus 3, like that. So you can also do the indexing and get the value of the arrays. For the 2D arrays also, there is the indexing. To get any value from this matrix, then what will be the index of this number 1 here? The indexing will be 0, 0, because in Python the indexing start from 0. So this one will have the index 0, 0. So if I print b of 0, 0, means the 0th row and 0th column element, So it will print that 1, the value is 1, right? Similarly, if I print b of 1 comma 1, then it will give you this value, right? 5. This is the first column and the first element, first row element, that is 5. That is 5. And you can also change or mutate an element inside the array. Suppose the B11 was 5. Now if you want to change this from 5 to 6, you can write like this, that B11 is now 6, not 5. Now if you print it, you see that there is 6 instead of 5. Here it was 5. Here it is 5, but now I have changed it to 6. You can also mutate the elements in the array. And there are some other stops, like how to get b of 0 means this 0th row, and b of 1 means this 1 number of row, and there is this b of minus 1 is this last row, and b of minus 2 will be this row, like this. These are not very useful, and you can also using this method. This is known as the slicing. Using this slicing, you can also get the arrays only the columns. So here you get the rows, and you can also get the columns, right? So 1 4 3 4 0 will be the first column, and here if I change this to 1, it will give you the this is B, and yeah, and this is B of 1. It will give you the second row. The second row is 2 5 6 0 0. This is the second row. How to get, sorry, this is the second column, not row. This is the second column, 2 5 6 0 0, and this is how you get the rows, and this is how you get the column. You can do it yourself, not very important, right? So these are all things you need to know about the arrays. And there is another lecture, just the extra things if you want to learn. These are here, how to do the slicing, not much important from our purposes. And swap elements, reshape, check elements, all of them you can study yourself, right? Okay, so that is all you need to know about the arrays. So let's take an example. In this example, you are defining two 2 cross 2 matrices like this. This is the first matrix 1 2 3 4, and this is the second matrix 5 6 7 8. These are the 2 cross 2 matrices. And how to do the matrix multiplication? In mathematics, you used to do the matrix multiplication, right? C equals to A into B, and you usually use some method called as the row into column method, and you use that method to solve them by hand. And you can also use Python to do that. It will be like C, this at operator at B. This at represents the matrix multiplication. So C at B, it will give you the result like this. This will be the result. And you can also use a function called as matmul, or matrix multiplication, and give the two matrices as input A and B. Then it will give you the result of the matrix multiplication, right? So this is everything you need to know about NumPy and Python, and from tomorrow we can start learning the numerical methods. Or the first thing we are going to learn about interpolation. Is it okay, or is there any doubt from this class? Okay then. So try to do these exercises and go through all these codes and play around it. Get yourself familiar with Python, or you can also use C to do all your stuff when I teach the numerical methods. Okay then. Uh-huh. Mhm. Yeah, yeah, yeah. Yes, I know. In C++ also. So that is the thing about Python, and that is also a disadvantage of Python, because we are getting very lazy and we are not actually uh, getting to know what is actually going with the algorithm, right? So when you multiply the matrices, you have to think about the algorithm, how to multiply each element with each row and column, using the row into column method. But here you are just using this just simple one operator, and it is giving you the result, right? So that is the thing. Okay. So are you a student, or are you a BSc or MA student? Oh, okay, okay. So yeah. Oh, okay, okay. Okay then. So have you gone through any course on numerical methods? Or this is new. Hmm. Okay, okay. So do you know about this interpolation and all these things, right? Oh, okay, okay, okay. So we'll learn about them in details, and I will show you how to implement them in Python. Yeah, if you know C, then Python will be very easy, right? It is very easy. Yeah. Okay, then so let's meet tomorrow, and tomorrow we will start with interpolation. Goodbye then. Bye bye. Thank you. Thank you. Bye bye. Thank you.